Yeah, where you left off last time talking about this UDP, basically the IP address was hard-coded, and the two devices were connected with a router with an access point. Like I said, you can also do this with certain microcontrollers, set up one to be the access point. And then, the server. Okay, so from a programming standpoint, TCP looks a lot like UDP. In other words, you've got an IP address that you're going to send it to. You create a payload. Okay, so how many do we got here? Do I need to wait? All right. Okay. We create a payload. Again, another JSON formatted device for fetching the weather. The particular starter code for this lab, I'll show it to you on the other computer, has 3 parameters you have to set in order to get to an access point: the access point name, the security, and the passkey, if there is one. But then when you go to request the weather, you deal with the format of the server. Open. This is the syntax of the format for getting weather from the openweathermap.org. Okay. All right. And so this is the starter code for fetching weather. I'm going to show you these things on the actual on another example. So I'm just going to skip this slide, except we're obviously we're up quite a few layers in the stack, where things like connect to the access point and open a socket. Well, that's connect to the access point there, but and then open a socket. Okay, let me go skip this. I just want to remind myself what it is I'm doing here. Okay. This is a hardware configuration. This is not an internet configuration. Again, SL stands for Simple Link. This is initialized hardware. This is the connect to the access point function call. Again, it's a stacked device where this is code running on the MSP432, which is sending a serial port packet to the CC3100 to connect to the access point. Next one. And then this is going to be on the test if you want to prepare, and that is, what does the domain name system do? It takes a ASCII string containing the IP, containing the web page address, the web page in human form here, and then again, this is actually going. This has to go to the internet because it has to go to a server that does the translation from the name. And this is IP4, so it's coming back as a 32-bit IP address. The cool part, yeah.
Oh, I have a quick question. So I pay for like a dynamic DNS service, so I can always like find my server wherever I'm at. So how does that propagate through the?
Oh, I have no idea. Whoosh. I don't know if you ever, when you.
I mean, it takes a few minutes. Like if I reboot my router and get a new IP address from Google Fiber, it takes, I don't know, several minutes for it to percolate through the system. But does anybody know how that update happens?
I don't. I don't. I know that there's more than one server that it can get from. Obviously, the whole internet doesn't use the same one. But I do know when you call this function, you get back a big Indian or a little Indian, I forget. You get back a 32-bit IP address into this protocol. And then this function here converts little Indian to big Indian or big Indian to little Indian, I forget, but it does the okay, this is a little Indian device, so it's obviously going to convert it back to big Indian. And as we mentioned before, when you go to a connection socket, you give it the connection. This is the IP address of the connection socket in the server and the port that you're going to connect to. So this is creating a socket. Again, this doesn't go to the internet. It just creates a data structure. This makes the connection. So this is the connection between the client, which this is obviously, and the server. And then once you're connected, you form a packet. You form a request and send it. And obviously this is a client server, so the server will respond with the weather. And this bad boy will crash. Well, all of these things can crash. All right, I think that's it for this one. Yeah, I want to stop share. Okay, I got one more slide, but I'll come back to it. I'll share it over here. Okay, share screen. Yes. All right, so this is a similar but not identical example. This is the IFTTT. I have this, if this, then that. And I'm going to send log TCP packets onto a Google Sheet. Okay, so I did a demo at the beginning of the semester, but now that I'm in the middle of it, I want to show you the parts. Obviously, this is starter code here. And so you're gonna have to type in the actual access point, the actual password, and the encryption type. So that was in simple link common.h. And then the other thing you got to do to get this starter code to run. Okay, obviously that's hardware. You just plug the booster pack right side up on top of either the TM4C or in this case the 432. This is a robot, so it's got a bunch of I/O. And the idea here is this particular code is going to barrel race, and inside of this message here, it's going to form a data dump of 3 different parameters and whatever, you'll see it in a second. But this is a dynamic data structure which will contain data which will get logged on the server. Okay. Crashing, running, racing. Okay, so that is the web page for which I'm going to do a domain name system fetch on when I do the connect. This is the web page to which we are going to post our log our data. This is the syntax of that post. Well, this is the first half of the syntax. Okay, this is the first half of the syntax up to here, and then this part is fixed, and the remaining part is added on. Okay, so this string here will get longer when I create an account. If you're going to do this lab, obviously this is not the right account number. You'll have to make an account on, well, first you make a brand new Google account because you have to give Google access to your Google Drive. Okay, well, obviously that's You got to give IFTTT access to your Google Drive. And so I would recommend you start with a brand new Google account. That way, when you're done with this class, you can just throw it away. Okay, so you logged, so that's the syntax. This code is, let me put the robot down so I use both hands. Over on IFTTT, where are you? IFTTT, here, okay. I've logged into my if this, then that account. And, okay, and set up a web hook. Okay, so the first part of IFTTT is if. Okay, and the if here is a webhook, which means when it receives a TCP packet. Okay, and then the second part is what do you do with that TCP packet? Okay. And that's the nature of this particular applet. And there are hundreds of possibilities. This one seemed the simplest to me, so that's why we did it. But the name of the applet is log data. So so there's really two connections, if you'd like, into it. The first is your ID here that tells IFTTT that it's you and your account. And the second is the particular applet that you're communicating with. Okay, so you're triggering this applet. So trigger is a keyword. That's the applet name. And obviously with key is the key. And then at the end of this crap, and I'll show you in a second, is a bunch of stuff. You can actually see it over here. Down here, this is the format of the receive, okay, which is going to be value 1, value 2, value 3, and I'll show you that format in code here in a second. All right, so okay, so going further, so you've got to make an account, you got to make an applet, call it whatever you want, but it's got to match right there. Okay, and now let's go through in time what happens. So I'll go down to the main program, and this is setting up the robot. Okay, here's that same similar initialization. That's initializing the interface between the 432 and the CC3100. Okay, so that's the link between the two devices. This, like the other one, was the connection to the access point. You can see if you hook up a serial port to the robot during debugging, you'll see a lot of debugging information that obviously has no use when the robot's running, but it's there for debugging. So that's connection to the access point. Okay, and then web page, again, was the maker ifttn.com. That maker, that's the web page address. And then it does the conversion. No, that's, yeah, I'm sorry. That's the call. That was just a printout. But again, you can single step over here and see the 32-bit IP address of the server when this executes. And again, it's not 128 bits, it's 32 bits. The robot, sitting there doing nothing until you hit a bump switch. And then this is robot racing. It's not very spectacular. It uses not Dead Reckoning, uses odometry. In other words, it's counting wheel turns to determine where it is. So, so it turns left until it's facing, it turns left until it's facing west. It goes forward until its position is there. It turns left until it's facing south, goes forward until it's got that position, etc. Turn left, forward, and stop. And each stage, it's going to log 3 pieces of information into the server, the X, the Y, and the theta, the direction. But it's not until so log data is just storing into the string, but send data is the thing that sends the TCP. So let's go back up and look at those. So again, log data is just a sprintf, which sends the data into a string, okay, where it's comma delimited, and then send data is a lot like fetching the weather. It will create a socket. Okay, this is again a data structure. Create a socket. This is now a TCP. This is a TCP socket. And so if you compare the code to the UDP, you'll see that field is different. I don't know why they didn't call it TCP, but they don't. That means TCP. And the other one meant UDP. This is connecting to the IFTTT server. And now we're going to, again, copy the log message, copy the values from the log message into this value, create a send buffer, which is a concatenation of log message and the request. And so this is a concatenation. The request, the size, and the log data is all concatenated into one message, which is sent to the server. Okay, so this is the syntax, if you'd like, this is the syntax of the IFTTT. We saw value 1, value 2, value 3. That matches this guy over here. Value 1, value 2, value 3. And off it goes, and then it all goes well, receives it back. Obviously, I don't even look at the received message, but if you do get something back, if you got the debugger on, you'll see that it will print stuff out. All right, so, okay, so now let's see. All right, so I'm gonna go over here. Where did I put it? Here, okay. So also on this is the name of the spreadsheet. You see, I named the spreadsheet there, and on my Google World, the directory system is, and I don't know why. I guess I mistyped it. I don't know why it's not webhooks. It's webhooks. I don't know if that happened. But you can see that that this is a regular Google sheet. Okay, so all right, turn the robot on. All right. The display should say it's connected. Yeah, because this is obviously I've got different code in there. I've got code which is connected up to my access point. And so the robot, if this were a class, we'd put it down on the floor, but it isn't. So I'm going to turn it this way so you can sort of get a sense of what it's doing. Okay, so you let go of the button, and now it's racing. You can see it goes forward, turns, goes forward. It's about 12 inches of barrel. So, and then if all goes well, over on my spreadsheet, ta-da, you see it right there. And this was the X position, the Y position and the theta, and you can see each time I did it, it started out at 0, 0, 0, and more or less, you know, got sort of back to 0 again. You know, got pretty close to 0. This second to last column should have been 0. And the theta, yeah, you can see sometimes it does better than others. Well, odometry is not a very good way to race. That's like running with your eyes closed and counting your steps. Okay, that's as good as odometry is. Okay, so like I said, I had an epic fail when I tried to create my own. We used to create our own websites with AppSpot on Google, but they changed so many things I couldn't really figure out how it worked. But if you want to log stuff on the internet, this seems like a fairly straightforward approach, because you can format this however you want. It just, these are the 3 fields: value 1, value 2, value 3, and you can put whatever you want in there. Okay. Again, that's the name of the. Okay, let's see, log data. Okay, so I showed you that. I showed you this. Any questions on this particular demo? Again, it uses a CC3100 on top of a Launchpad. We've done this on top of the TM4C 123. So it's, as you can see from the code, not spectacularly complicated in terms of how it does internet. So as a final slide, is going back to the where all these example codes came from, and this CC3100. If you all the examples that I just showed, well, not the UDP. The UDP example was the second to the last one down here. And the TCP examples that I showed you really were derived from, all of them were derived from Open Weather Map, because they basically give it a web page and you give it a JSON TCP packet, you send it, you receive a response from the server. But I haven't even in the lab, even in the lab assignment, there is a step for sending email, but it's not using the send email. Again, it's using the get weather, using IFTTN, because that was one of the other things you can do on a trigger, is to send an email. But I haven't tried very many of these. Again, I've seen students come back with the fact that they can create a server and connect it up to you know, as a client. Okay, so that's why that's internet. Okay, not stop share, stop. Discard. Well, as you probably know, there are an infinite number of ways in which you could implement internet. Okay, and so it's not meant to say that all internet has to use a CC3100. It's and as you know, even in 445L, we went away from the 3100 and used the ESP 8266 so we could use Blink. And so we could buy them all and give everybody their own ESP. So one of the downsides of the 3200 is a $20 board. And if we want to give it to every student, it became expensive, where the ESPs were like $4 or $5. And so we could spread more spread more, DNA out there by giving away the parts. One more questions on that before I go on to a completely different topic. Okay, so that's basically all I got to say about lab 3. Okay, and that is I want you to be able to, yeah, let's review what I want you to be able to do. Okay, that is still open. Yeah. Okay, we'll see. It was actually the previous one. Yeah. When you, however you do lab 3, these are the basic steps of doing TCP IP. Okay, you're going to have to connect to the internet somehow. It could be Wi-Fi, it could be Ethernet. Well, we'll see. It could be thread, although I don't anticipate you using thread. Somehow you have to get the IP address. Sometimes we're a scoundrel and we just hard code it, and it works for a while, and then we got to hard code it again. But the idea of internet communication is creating a socket, which occurs at that TCP level, and it's through that socket we send and receive TCP packets, which are basically ASCII strings formatted at whatever format the server expects. Yeah, so unfortunately, I got thwarted at my efforts to show you how to write the server code so you could have your own format. But suffice it to say, it is possible. And so the 2 lab configurations we had were OpenWeatherMap.org and IFTTT, where the structure of that TCP socket, that TCP package was already given to you. And then you close it. Okay, that's the plan. Now for something not completely different, but sort of, I don't know if you, but I'm almost in this class, I'm almost in a daze, because every time I open up a new protocol, I see exactly the same figures and exactly the same numbers and exactly the same things. And so if there's one thing I want you to get out of this particular half lecture, like I said, I'm going to be done before class is over. Oh well, we'll stop early. And it's obviously called 6-low wireless personal area network. Okay, so again, it's a low power. I don't know what the 6 stands for. Should have looked it up. But it's a wireless personal area network. And the reason why it's in this chapter is because we will bridge to the internet. Okay. And so this is really 2 networks, if you'd like, connected together. Okay. So it is the regular internet, which we did in the last couple of slides, PowerPoints, and the 802.11.15.4 personal area network that we did in the previous chapter. Okay, so it's sort of a connection between 2 networks, a personal network, okay, which exists, and the real internet. Okay, so they're connected together. It does use IPv6, which is 128 bits of addressing. But okay, so let me start. So this is an edge. This is an edge network, which means its main purpose is sensor data collection or actuator output, right? So door locks and refrigerators and things that do things, washing machines and car chargers and things that have real time, or at least dedicated input devices and output devices. And so it's sort of meant for your your home application, for inside the house. That's kind of where it's going. It does provide for mobile connection, so it will connect and reconnect. And as you'll see in the pictures, have multiple ways. It's a mesh, right? It's a mesh network, which means there's more than one path from A to B, right? And so it has to discover, when it sends a package, it has to discover its networks. Okay, so connect them. So an edge router, okay, is the bridge. Okay, so like I said, there is a bridge between the local and the world. Okay, it is meant to be low power and simple, and so it's gonna downsize a lot of the things that are complicated in IPv6, like the headers, like the IP addresses, et cetera. It's going to downsize it to very small amounts. Okay. And then there are three types of nodes, and I guess I'll show you the picture. There are three types of nodes here. Okay. The first is a edge router. Okay. And the edge router is this one, the bridge. Okay. So there are my edge routers. Okay. And the dark circles, right? These are 6 low wide wireless personal area networks. Okay. Okay. There's 3 of them here. So a network might have one edge router, it might have 2 edge routers, or might have no edge routers, in which case it's essentially just an ad hoc, is actually a completely personal area network with no internet access at all. That's perfectly okay. And then we have host nodes. Okay, those are the endpoints. Okay, host nodes, there's one. See them here, which do input output. Okay, so they're the actuators and sensors. Okay, and then we have one more. We have these router nodes. Now it turns out, we'll see in a subsequent slide, an actual physical device could be enabled to handle all 3 of these tasks, and it could switch from one task to another. But a router node is one which has the ability to connect. Right, to connect, here's an easy one, other devices. So a host can talk to a router. Okay, a router can talk to a router, but a host cannot talk to a host. You see that in this mesh network? And so hosts can talk to routers, routers can talk to hosts, routers can talk to routers. Okay, and the edge router is a router that can connect up to the internet. Okay, that's all right. So when you look at one of these stacks, they all have stacks and they all look the same to me. You can see that basically, if you were to make a general statement of 6 low wireless personal area network, that it's basically, right? If you look at the stack in this direction, what do you see? What do you see logically if I draw the line there and I look up? What do you see?
Normal internet.
CPU,
And it
DP.
looks like the internet, right? It looks like a TCP IP. It looks like, you see, it's got UDP and TCP, and we haven't talked about MQTT or CoAP, but it looks like internet. Okay, up. If you look down, what do you see?
is 15.4.
Yeah, so you see sub-gigahertz. Right, so sub-gigahertz was meant for low power, low bandwidth, right? It was meant for low power, low bandwidth applications, and not extremely long range, but long-ish range, not real short range, but you know, a couple of 100,000 feet range, okay? But low bandwidth. Okay? So it's, whereas if you think about the internet, normally you think of high bandwidth and essentially plug stuff that you have to plug in to the wall in order to make it work. And so this is could be battery powered, or at least low power, or even energy harvesting, okay, power. Okay, so you could have a solar power, a solar, a solar panel and remote devices, and it could also be mobile. Okay. Okay, so this level here allows for the mobility, so these things can move around and reconnect. Okay, so if there's one thing you get out of this particular slide, it's the marriage, the bridge between a sub-gigahertz mesh, right? A sub-gigahertz mesh and the internet. Okay, that's basically the nutshell of what you're going to get out of here, out of this particular slide. Okay, so again, you're going to, when you send messages across the network, you basically have the destination address in mind, okay? But you may not be connected to the destination node, and so it has to hop, right? It has to go through a router, and there are two routing mechanisms. There are two routing mechanisms that you can configure. This one here is a low intelligence way that basically routes through the data link layer. It's called under network, mesh under, and then route over. You have access to the, because you go back and look, where's the data link layer? Where's the, right? So are you routing through the MAC layer, or are you routing through the 6-low WPAN layer? Okay, those are the two routing layers. I don't physically know how this could possibly work, because this layer doesn't necessarily know where things are, but it might work for simple networks, I guess, where there's a single, might work for this kind of network here, where there's a single router and a one hop distance, where whenever you want to send it, you send it to the router, and the router is connected. The router could, this layer could know what it's connected to, and therefore know which direction to go, right? But whereas at this layer, the network can discover its topology and configure and know which way to send stuff when it needs to send stuff. Okay. As mentioned, you're going to, it has a very low, has a very simple, header, right? It's not very long. Here's an exam question for you. What would you use hop count for? Well, hop count is the number of times the message is hopped in your network.
For timeouts and stuff.
Yeah, sure. So if you go back here and pick a network, right? Let's say it hopped 6-7 times, right? Hey man, you did something wrong. Throw it away. Okay. So if you hop too far, too long, you're going to say it's not deliverable, right? So it's going to a error detector, right? So things don't hop forever, right? Because at some point you got to give up. And as the hop count gets too large, you can use it to reject. Don't send it on anymore. Send it back as a failure. Okay, this is the same slide, but with more terms to it. Like I said, it's okay, no, take it back. That was 6 low WPAN, okay? And I want you to remember this, and you see here that it's basically all of the internet, okay? If you decide to reduce the amount of internet you're willing to deal with, okay, you can go lower power and simpler, okay? And that's what thread is. Thread is a subset of 6 low WPAN made for simple networks. You got data on the farm, you got data in the factory, you got data in your house, you got data in your car. You know, basically it's a personal area network, right? So it's all your data. So every node is reliable, even though you can have security, you can encrypt crap, but it's a personal area network. Okay. And now we're going to see those same three terms again. We saw over here, we called it a host, right? You remember the host was an endpoint. And over here, it's called a router eligible end device, okay? And a router eligible end device may be full functioned, okay? Which means it can conform itself to one of the other possibilities, or it might be a reduced or minimal device, which is only an endpoint, okay? And again, the endpoints are on the network, connect to the sensors, connect to the actuators, you know, door lock, temperature sensor, fire detection, whatever, you know, a CO2 detector, a carbon monoxide detector, et cetera. Okay. And then the border router, okay, I don't know, they renamed everything. The border router is the edge router, okay? The bridge router, okay? The border router here in a thread is the border router. And then then we have, you know, then this one is the connection one. So that's again, they renamed everything. I should have drawn these on the same slide so you could see what I was talking about. Is these routers here, the ones that can do the connection. So in this picture, it's called router, and over here, it's called thread router. Okay, so that's actually not too bad. Okay, so a minimal end device can only talk to a router. Routers can talk to routers. Reads don't talk to reads. This is a mesh again. Okay. But they've added one more thing, and that is one device becomes the lead. Okay. And so apparently it handles managerial tasks. And so now, okay, so now we're going to draw the line again here, right? Oops, come back here. Okay, in terms of the stack. And now when I say up, we don't have all the internet. What's missing? What's missing? It's internet, but it's internet light. What's gone? Can you see what's missing? The thing we did earlier today. What's missing? What's not here in this thread going up?
TCP.
There's no TCP here. And so this then lets you know what their agenda is, right? So what are the differences between UDP and TCP? Basically, when do you use one and when do you use the other?
I mean,
UDP is faster.
This is fast.
Security is
TCPs
not
were-
as much of an issue.
reliable.
Yeah, so this is reliable and more secure. Okay. So you're giving up reliability. You don't care about packets. This one's ordered. TCP packets are delivered in order. Okay. UDP is meant for fast reliability and security, authentication, all that stuff, and doesn't have to be in order. Okay. So it's meant for, again, simpler, right? The whole idea here is this becomes this is much simpler than a full internet. Okay. And so again, thread is probably best described as UDP over sub-gigahertz. And the advantage of having UDP is it still allows you to do some high-level things. You're just doing them in a less reliable, less secure, unordered manner. Okay. And that's a thread. And one of the reasons, I never made a lab out of it. One of the reasons that I just try over here. Share. Stop share. Okay, share. One of the reasons that I chose the 1352 was it will do thread. Okay, so I'm going to do properties. Now I want to go to where is it? Projects. Switch workspace there. So the cool part is that there is a large number. Okay, can you see? Yeah, you can see the screen. Okay, so I'm in Resource Explorer, which happens after you've installed the drivers, et cetera, for the 1352R. Now, again, I'm not a salesman for Texas Instruments. All the ones other than the Arduino community, okay, in the ESP community, all the real manufacturers, Silicon Labs and Nordic Semiconductor, and all the real places that generate IoT chips have this sort of approach. In other words, they want you to buy their crap. And the difference between a company like Texas Instruments, Nordic Semiconductor, Silicon Labs, and the Arduino ESP community is this approach is meant for real practicing engineers who are going to do this for 6 months, right? We're not a hobbyist who has an afternoon free off work and wants to let the lights flash. Okay. And so this then becomes a lifelong, and well, not lifelong, but at least months-long endeavor that ends up in a product you're going to actually sell. Okay, so having said that, so Simple Link is their moniker for everything, by the way. They even renamed the TM4C as Simple Link, even though it's got no wireless in it. And then we go to the specific board that we've purchased, and that was that red board, that CC1352R, which is essentially the sub-gigahertz part, and Bluetooth. So this one has 2 radios on it, the Bluetooth radio at 2.4 gigahertz, and the sub-gigahertz, which was 900 something, okay? And I did this example here when we did sub-gigahertz. Like we did the collector and the sensor in the sub-gigahertz. But here there is a thread set of functions where if you want something that's like a door lock, okay, so introduction. So you can see that this is a minimal thread device, and again, they use another end, another name, but this is an edge device. And you can see from this particular network that they're going to create basically a pairing between two devices over thread. Whereas if you look at, let's see another one. Looked at a couple of these. Temperature sensor, is that the cool one? Yeah, see this one. They're going to create a network with 3 1352s and 1 BeagleBone. And those of you who don't know what BeagleBone is, like a Raspberry Pi, but it uses TI parts. Okay? So a BeagleBone is a Linux-based single board laptop, right? So it's running an A9 or whatever, and it's it has a controller and multiple nodes. Okay, so and it uses constrained application protocol, again through over top of UDP. Okay? And so eventually one of this course will get harder. I don't know, maybe not. I don't know. We'll see next year. But a thread lab could have been one of the choices. And this would have been way easier if we had a room and a place to set all this crap up. But full function device, minimal function device. Anyway, thermostat. Again, it's using constrained application protocol. I guess I'll create some slides on it eventually, and across UDP, across thread. Yeah, here it is, 10:23, and I ran out of slides. I know what I can do. Stop sharing here. We can do some planning. Let's, okay, so some of you, okay, let's go over here. Share, quit, calendar. Oh, I want to share. I want to go to, get out your calendars. I'm going to ask you to think about when you want to do your project presentations, so I can finish off the rest of the semester. Okay, so open up. Okay, so the most natural place to do a project presentation would be December 1 and 3. Okay, I have to log on. Why can't I? Yeah, I'm logged in. So, okay, so I'm about ready to ask who wants to go on the first and who wants to go. Let's put 2 of them on the first and put 2 of them on the There we go.
How long are the presentations?
Probably about 15 minutes per person. So 2. Yeah, so 2, yeah, so probably 15 minutes per person.
Ten minutes
And
per person?
no, 15 with questions. You gotta teach. I want you to teach. This is a teaching moment. I want you to teach the class something that they may not have gotten from their instructor. Okay. So, yeah. Yeah, you could show code. You can do all, 15 minutes is, you can show data. You could do a demo, right? Or not. I don't care. You could do record a video of it working. No. So, okay. So what I'm after is, which one of you is most likely to be done first? And we'll do it on December. Or who has something? I could do it earlier. I mean, if you got I do believe 3rd is the last class day. I'm pretty sure. Now, I mean, if you wanted to do it before Thanksgiving, you could, but that's like next week, right? Almost. Now, here's another one. Okay, some of you have promised to give a some of you have promised to give a class demo, a class description, right? Remember who said they would come give us how you hacked into the security thing?
Yeah, that was me.
That was Ben. Okay, so now Ben, I'm asking what day you want. And again, I don't know how long, since I'm asking you, I need to know how many minutes you want with questions. So we've got the 17th, and I'm gonna know, because it's right. I don't want you to do the 1st and the 3rd, Ben, because, all right, so okay, 17th, 19th. All right, Ben, which one of those 3 do you want? 1.5 hour? You want 45 minutes? How much time do you want?
I mean, how much do you want me to explain the
Oh, I
theories?
want you to teach. If you can teach, okay? If you can actually teach, you can have the whole 75 minutes.
Okay.
But I need to know so that I can schedule, because now I'm at the point where I can't necessarily fit everything in, and I'm going to, right? Right, we're done with chapter, whatever number that was, chapter 5 or chapter 6. And now I've got a couple of big things I want to do: long range, near field, and so I want to get them in. Yarabali's going to teach a lecture, and I got to get him in here. So I need to know how many minutes and what day, Ben.
I'll probably use all 75 minutes if that's okay.
Yeah, pick which
And
day.
then maybe
Pick
the
it.
24th, so that'll be right before Thanksgiving.
Okay. So yeah, so give me a title, so everybody gets all excited, so they come. Yeah, yeah, a teaser title. Like I'm not missing that lecture, or as Keyshawn will say, is it on the test? And the answer is yes, but he's going to do lab 5, so he doesn't have to take it. Okay.
You just call it
You
hacking
chat-
the NRF 52840.
Okay, wait. I'm sorry. Okay,
I put it in the chat.
I see it. Okay. Yeah, so this is And it's the platform you're using it for was Bluetooth?
Yeah, although it could be applied to different communication, I suppose, but yeah, mostly Bluetooth.
Was it low or is it just LE or just T?
Yeah, I think it's BLE.
All right. Well, it don't matter. I'll take it out. All right. So, yeah, this is good in a sense that we really haven't done much security or any security. And so this is an example of how security is used properly or improperly, right? Yeah, good, good. Is anybody else committed to giving a lecture or part of a lecture or want to? Other than their project? Okay. Like I said, I'm going to negotiate with either Pierce or I haven't done it yet. I'm hoping to get somebody to come talk about antennas. Yarabali has come to give you a lecture, and I will announce it when I get the exact title. I don't mean to be rude, but I don't want you all going on the 3rd. So the actual report, as Austin has requested, which I didn't actually give an answer to his answer.
Well, when is the test?
Oh yeah, it's great. When is the test? Oh, great. Yeah, that's right. When is the test? Fine, maybe you're right. Thank you.
I'm not taking it. I'm just.
I know, but you're right. I don't want everything at the same day. Okay, how do you like that? 17th. There we go. Good. Thank you. Perfect time. Thank you. Thank you. There we go. Thank you. That was very useful, Keyshawn. Yeah, that's what I was trying to do, make sure I don't get to the end of the semester and say, oops, I forgot to give you a test. Okay.
Are you wanting us to sign up for slots now for the presentation?
I'm asking a very delicate question, and that is which, I think there's 9 of you, which means there's 4 groups. Does that sound like, do I got that right? And so 2 of the groups are going to have to go on the 1st, and the other 2 are going on the 3rd.
Jackson and I will go on the 1st.
Okay.
Yeah, me and Adi will also go on the 1st.
Okay, there you go. Okay. All right. All right. And then it puts the other 2 groups on the 3rd. Cool. All right. And report is going to be due probably 2 days. And I got to find out before the drop dead date for the grade. I got to find that out. Yeah, as I mentioned before, there's a date. It's like 10 o'clock in the morning. So, there's I know it's at 10 a.m., but I just don't know which day it is. 10 a.m. someday is I have to get the grades in. And so assuming I want to read it, you've got to turn it in before I have to actually give the date. There is a dean sends Valvano a nasty email time.
So for the report, like one class period, you said single spaced, and the next you said double spaced.
Okay, so what did I write? Did I write anything down?
I forgot, but I knew.
Okay, let's write it down. Let's just decide. Okay, I don't care. I don't actually care. Report project. Where's the 20? Oh yeah, see, there you go. So you already got you on there already then. Okay. 19. All right, somewhere else. Oh, I don't care. Okay, double space is the answer. Double space is the answer.
Okay.
Okay, but let me write it down so I don't forget. And don't. GMT. Okay.
And it can be in like just like Microsoft Word. It doesn't need to
course.
be like a research
No.
paper.
No, please. Now it can be, yeah, okay, so, okay, going back here. All right. No, it can be on, okay. 20 pages, double space, times 12, or any other font that's about that size. Not including software code.
Professor, I had a quick question on the student lectures. Did you say those are only like 15-minute topics?
Well, 15-minute each, right? So since if there's, right, so it's a half hour for two of you.
Got it.
Yeah, so per person.
Yeah.
Well, we got 75 minutes, right? So on this date, right, there's really, that's full, this is a full 75-minute, right? Because it's 5 times 15. Whereas this one, there will be at least time to sort of figure out, how we're going to do it, to sort of work out the kinks of setting it up.
Gotcha.
And it's I don't know. Yeah, it doesn't have to be strictly. How I don't know if you when you did your senior lab, there was somebody with a stopwatch, and was timing you, and you went around the room. As long as you both speak with something intelligible. And again, my objective in the 15 minutes in this is for you to present to the rest of the class something that you've learned that you wish they would learn. Okay. Because there are certain skills in the classroom that your professor doesn't have, and that's your opportunity to cover that hole. Okay.
Sweet. Awesome.
Yeah. So, so it can be a mixture of, it can be a pre-recorded. It's always a good idea because, pre-recorded demo. It could be, it's a little safer to do, or at least to have it as a backup in case your thing blows up. Yeah, but again, you want to give them a reason to come listen. Okay.
Yeah. All right. We'll do. Yeah.
Yeah, 10-4. All right, good. Thanks, Keyshawn, for reminding me about the test. So we are done with what's on the test, by the way. Okay, I'm pretty sure of this. This test, there's more stuff, but I don't think I'm gonna. Hold on, where's my exam thing? I don't know. We'll see. I'll create a study guide for it. Yeah, chapter 6. Yeah. So we're actually done with what is going to be on the third quiz. And yeah, see, so this is okay. But Austin asked me, not Austin. Austin asked me to consider redoing this. Okay. I don't actually care when you finish the labs. If for some reason, you know, we're fussing along and you haven't finished one of the labs, like, or if you do really poorly on the third exam and want to do a lab 5, that's an okay thing too. All right, so now I've used up the rest of the time. Okay, cool. But does include, you know, tables, figures, flow charts, you know, the usual stuff. Yeah, requirements. Performance. Okay. Any questions for me?
Hey, Professor, I had a question about the LoRa lab. So we can take it offline, or I just wanted to talk to you about some of the requirements that you like to see in that.
Okay, so yeah, so let's just okay, so the way to answer that question, let me go back to here. In this one. Is when you do something, when you do a lab that's not completely specified, we'll break your process into 2. One is what hardware you needed, and it's just going to substitute here Wi-Fi. I'm going to substitute LoRa for Wi-Fi everywhere in this thing. I'm going to stop recording. I guess, okay, I'm going to stop recording. Where's mine? Stop. Stop. Stop share. Okay, I'm going to have to stop.